applications. Containers are a really big thing right now. Make platforms as a service super easy. You can just add a container and say how many you want, and then you have it, and your application works. Your developers can be working on the same code, working in the same condition as your deployed instances with like a Linux virtual machine. And then microservices, the whole idea is instead of one monolithic, you have lots of little things that do different functionality and they're all connected. The main thing to keep in mind with microservices is they're a little overrated right now, in my opinion. You don't need microservices for like 99% of your problems. If you start out with microservices, you're doing it wrong. You will know if you need to start breaking down a monolith, and then you start breaking into smaller services. You don't necessarily need to start out going micro, because it just adds a whole other level of lots of problems. A lot of the stuff I was talking about, you have to address for a small application that you shouldn't need to address. It's really interesting if you look at like Amazon's AWS talks. They're huge proponents of microservices, and they say like Amazon.com. Supposedly there's a microservice that manages the rendering of the buy button. So that kind of scale is pretty crazy, but. Yes.
Well, I'm sure Amazon wants everybody to be writing microservices applications, because then you have to buy 85 S3 instances or EC2 instances.
Yeah, no, it definitely doesn't hurt their business model if everybody's got, a million servers that are already using half a gig of RAM when they're paying for 2 gigs of RAM. Yeah. Okay, so only when you need it, don't start using them. It really is an early optimization, and the definition of micro is very subjective. There's definitely service-oriented architectures that are nowhere near a microservice and will suit you fine. Really, a lot of times you end up realizing you just have to start reusing code anyway. If you're writing your library in Java, you have your Java classes. When you have microservices, you're going to want to start reusing that Java code. You have to make sure that it's packaged more as a library than as functionality that's baked in. There's a lot of different. You have to make sure that your microservices are actually disconnected as opposed to being connected. Yes.
So this actually seems incredibly surprising to me, because it seems like a lot of design paradigms involve having scalables to do very specific things as opposed to gigantic monoliths. But it seems like you're proposing a monolithic.
So I'm not supposing a monolithic. It's a lot easier to build a monolith and break it into smaller chunks as you need it than to build a million smaller chunks that make one cohesive whole monolith.
So is it just a natural design process that you start with a monolith because you have low scale, and then as you scale, break it out into
Yes. And you don't even have to make it into microservices. So microservices kind of like, we have this service that handles, this service handles user deletion and adding. Like that's really, really micro, right? As opposed to, you might have a service level where, you have an authorization server that handles like sessions, and then you have handling the rest of your requests. Something like that is a lot easier to deploy, manage, and develop.
So is a microservice a final evolution of the thing? Is this a good thing to do once you're beyond a certain scale, or is this a lazy cop out from just having to deal with gigantic amounts of traffic?
It really depends, but
It just seems weird.
It's the big new thing. And I just wanted to make sure you guys know that it's not like if you're not building with microservices, you're fine.
It sounds like pain. I was just curious.
Basically, you have to make everything, like microservices do one thing, literally one thing, and a service is like
I don't know.
a bunch of microservices together, sort of.
Yeah, what's up?
I feel like the overhead is really where the tipping point is, because everything now has to go through it with some sort of bus talking to each other.
Yeah, I would agree with that.
So like I was saying, you don't want to break microservices if you have if you have a custom built library that interfaces with your web server, breaking that out and putting it into a separate module that you then use for processing images or something.
Okay.
Any other questions? I think that's all I have for now. Do you have any questions, Kevin?
What was the hardest thing on shape as far as like, I don't know, either learning or what was the biggest like mental shift in design that you did after seeing that much scale?
So Onshape actually isn't crazy amount of scale, to be honest. You know, versus like what we do, which is like 2 servers, versus what they do is like hundreds of servers. Hundreds of servers is nothing compared to, you know, Google's doing thousands. One of the, probably the biggest thing for me was realizing like what you need to start doing when you have, like, how much goes into just managing the servers that you have when you have a lot of them. There's a lot of work that goes into the log congregation and the monitoring and making sure your app has uptime, you know, things that, you know, you start realizing you're not just building features anymore, you're building like a whole like cohesive system. So that was a pretty big shift for me in my thinking. Yes.
Does Onshape use Redis?
Does Onshape use Redis? I don't.
If you're
no,
allowed.
we don't use Redis.
What's Onshape stack look like?
So yeah, I feel like this is fairly confidential. Like, but
You know, I'll just talk to you in your room later.
basically, yeah, like general knowledge is Java with MongoDB.
Well, you can absolutely, they use Parasol. Parasol is written in C++. And then they use other languages that have to do a lot of shuffling between Parasol and other things.
Okay.
So they're kind of hamstrung by the fact that they don't like writing C++, but all of CAD is written in C++, so they're fine.
Okay.
That's all public information.
Including that they don't like writing C++.
No, that's.
I mean, people don't like writing
A lot
web,
of
C++
people don't like it.
for web.
Yeah.
I love C++.
Why would you write a web server in C++?
We're good.
Yeah.
So I'm trying, let's say hypothetically, I'm trying to build something that shouldn't require more than one developer input, or should require like 1 or 2 developer input. Simple product that I hope to be used by a ton of people.
Yeah.
What would you recommend I build that in terms of like turnkey, like cloud hosting services that'll just handle all of the scaling for me, or any sort of like service if it's cheaper to just buy EC2 instances and.
Yes. No. So actually, like for something like that, if you look into like Elastic Beanstalk, Heroku, really the price per, you know, the price per instance goes up, but the features that you add are like scaling. So Elastic Beanstalk will like let you have like rules where if you're, you know, the Elastic Beanstalk is AWS, Amazon Web Services, Heroku style control of systems. So they let you scale. You can program to scale. You can program or not. But basically, it really allows you. One of the big problems is when you start, if you start building and build it yourself, is you start having to do like your own like like what I was saying, discovery of services, or you know, have a load balancer that manually configured to point to like 3 different instances or something. But you don't need to do that. So Heroku and Elastic Beanstalk let you very easily just give them your code and say how many you want, and it does all the rest.
Bobby? Very good. Very proud.
Do you like doing like scaling stuff?
I think it's really interesting, but
Well, that's a little different than do you
Yeah.
like doing.